off we go. So today is going to be a programming lecture. We're going to talk about some more Python. So go ahead and open up idle or reinstall it if somebody accidentally restarted these computers. They uninstall everything. But get back in idle because we're going to make some new programs today. We're going to learn some new stuff. All right. So the goal is to, first of all, learn about conditionals in Python. That's a way to branch based on whether one thing's true or another thing's true or false. And so that's great. That's where we're going. And to get there, we'll have to do some other stuff. And then also we need to talk about how to draw cooler things.
Yay.
Arbitrary shapes, maybe things that are filled in even. Let's see. We're at least going to learn how to change colors in Python Turtle Land, which is going to be fun. So yeah, let's talk about conditionals in Python. So what is the equivalent in Python of this idea from scratch? It was you have your if then else kind of thing. Let's see if I can draw it. It looks like an E almost. It's got room for some pieces. And so you had your if, right? And then you gave some sort of Boolean producing condition, some sort of thing that became true or false. And based on that result, you either did the then part, the body of the then, or the else part. So if this is true, then do this. Otherwise, right, else do this. Otherwise, or else, otherwise, I guess we can say, do that. And that's the goal. And what is that in Python? How do we do that? So there's no blocks. It's gonna end up being just straight lines of code, but how do we do it? Well, we'll see. All right, so we need a new type, a type to talk about whether something is true or false. That's the bool type, short for Boolean, of course. And so the bool type is a very small cloud. Right? It holds very few things. The bool type only holds true with a capital T and false with a capital F. Those are the only values in the bool type, which is great. That's very different to the int type, right? What are integers in Python? You have infinitely many integers. You have whole number. They're all just whole numbers. Could be positive, could be negative 42, negative 42, all the way to positive and negative infinity. That's great. But bool just represents the idea of something being true, the answer being yes, or false, the answer being no. Okay? So just like we were doing in Scratch, we can use that true or false, some expression that produces true or false, to control how a program runs. It's great. That's where we want to go. So we can be do one thing if the result is true. Do another thing if it's false. You have a variable sitting somewhere that maybe is an int, and you can ask hey, is n less than 7? Question mark. And so that kind of question is something you can ask for. You can ask about something in Python, and it will say yes. And the equivalent of yes in Python is true with a capital T. That's the idea. And so you can branch based on that. So you can say, hey, Python, is n less than 7? Go and check that. And if that's true, if that becomes true, results in true, do one thing. If it results in false, do a different thing. That's going to be how it works. All right? And you can ask multiple things, if you have this n variable and it's 5, yes, 5 is less than 7, but is n less than 3? You can ask that as well, and that would be a false answer, right? Because the answer is no, n is not less than 3. No. And so that would result in false. That's what Python would tell you. That's false. And yeah. So these expressions result in true and false, and you can give those to the REPL. And just be hey, is 2 less than 3 true? Is 5 less than 1 false? It will evaluate and print out the answer like that. You can also just make a Boolean variable if you would like. Set a variable to either the result of something or just hard code true or false. You can be B. B is a variable that holds true. That's totally possible. You can set variables based on this too. Okay? So that's the goal. That's where we're going. And let's build up something slightly cooler. So let's make a new file, first of all.
Okay. Get that.
I'll go to File, New File, get out of the REPL, and I'll call it bools.py. Bools.py, and I'll save it somewhere that you can have it later. So that's going to be on my desktop. Go ahead and save it wherever you would like. Let's see. Got a folder. Let's see. Lecture 18 is what we are today, so I sure hope that was numbered properly. So Lecture 18. At least that's where I'm going to put it. Bools.py. Cool. Empty file I have now. Well, let's see what we can do. So first of all, true and false, you can just type them out. True, false, those are literals in Python. It's happy just understanding those things. You can be like, hey, print the type of true. And the type of true or false is a bool. Run module. So like, oh yeah, that's a bool. I got you. So Python remembers types of things, of course. And then you can shove booleans into a variable. You can be like, hey, b is equal to true. And then you can print b. You can do things with b. So we'll get to that. But that's the idea. Print b, or like print is 2 less than 3. That's another way to print true, right? Or maybe we can do 3 less than 2. Because that'll print false. That's a false statement. Okay? Any questions about that so far? It's just a new type, but it's going to keep track of yes or no answers for us. That's something we didn't really have to worry about in Scratch. It was just the pointy things became true or false. But in Python, it's like, if you're not careful, like you'd be printing a number, right? There's no separation like there was in Scratch. So yeah, here are some ways to get booleans or bools, values of the bool type. So a Boolean expression is usually what you'll use. It evaluates to true or false. A Boolean expression is just any code that results in a true or false value. And so, for example, you had x less than y or 2 less than 3. There's, of course, greater than. So like if you have two variables, you can check, hey, if these were the values of these variables, hey, is x greater than y? And that would result in true if those were their values. That would be fine. So greater than exists. It's very hard to type this character and this character in a computer. And so instead of saying those, you say less than or equal to and greater than or equal to like that. You just put the equal sign afterwards. So that's a thing. So let's just go back to the REPL and I'll show you that. Like, hey, is 2 less than or equal to 2? Yes. Is 3 greater than or equal to 1? Yes. I just put an equal sign there too. And it works. And then there's a quality check. So remember that equals is already overloaded, right? You can't be like x equals 42. That doesn't check for equality. It sets a value into a variable, doesn't it? So we can't use the equals, a single equals, to check for equality. So we have to double it up. Double equals checks for equality. It's like, hey, is 2 equal to 2? Yes. Is 2 equal to 3? False. Does that make sense? We've already used the single equals for something else. We can't do that. And then this is not equals to, because it's, again, hard to type this character inside of a computer. So instead of that, they use the exclamation point. You pronounce that as not, and that means check if it's not equal to something else. So like, hey, is 2 not equal to 3? Yeah, it is not equal. Is 2 not equal to 2? No, it is equal. Does that make sense? So you can check for that negation pretty immediately. So that's that one. Let's see what else. What was I going to do in code? And then finally, you can do your combinations of things like we've been talking about. We have our truth tables. We know about these. You just spell them out. Like, I want to do this and this. Compute this ORed with this. Or not this. All right? That combines 2 Boolean values for and or into a final Boolean. And then not takes just one thing. Okay? So this and or are ways to combine Boolean expressions. It's like, hey, is the age... Like, if you're going to like make a program to check if somebody should ride an amusement park ride, if you're going to go to the fair, maybe. If age is greater than 12 and, you just type it out, and height is greater than or equal to 48 or something like that. Something like that. Greater than or equal to. That's a way to combine conditions and result in something bigger. Okay, remember what and does, right? It's like if x and y are true or false, some combination of them, x anded with y. Remember what that gives back. It's like if they're both true, it gives back true. But any other combination, it gives back false. They both have to be true for the final anded thing to be true. True, false, false, true, false, false. Every other one for the and at least is false. Okay? So that's how you combine conditions. Like, hey, is true and false true? No, it's not. Only true anded with true is true. But obviously, you're never going to type that out yourself. It's like, hey, is 2 less than 3 and is 5 less than or equal to 7? Something like that. I'm like, yeah, that's true. And then or and not are the same. Remember that not negates things. Like not of true becomes false. Not of false becomes true. So yeah, let's type some of those things out. Like, what is, if B is true, let's see here, then we can print, I don't know where I want to put this. If B is true, then printing not B will produce false, won't it? That's the false printed there. And then the equalities. Make sure to watch out for those doubles. Right? It's got to be 3 is 3 equal to 3. Double equals. Print is 3 not equal to 3. That's how you check for equality and disequality in Python. It's like true, yes, they're equal. False, they are not unequal, is what it's saying. False. They're not unequal. It's a false statement. So yeah, I think that's what I wanted to say there. Does that make enough sense? Are there any questions about that? So we know these concepts. We've seen them in Scratch. It's just slightly new syntax because it's got to be typed out in Python. All right. If we are happy, let me ask you a question that's going to help you understand this. So let's say I have some numbers that I like and some numbers that I don't like. I'd like you to figure out which of these options, if you go to the by clicker page, please, and you'll, after I explain it, feel free to help each other, the people around you. Oops, apparently I've logged out. There you go. By clicker page, start. So which of these expressions results in true when x, pretend that x is a variable and it could hold anything, but I only want x to be able, but I only want x to hold these blue values. X, I only want to be 4, 5, 6, 7, 8, or 13, 14, 15. It could be any of the blue ones. Can't be any other number. Okay? That's what I want x to be. And I'm not sure what x is. Which of these expressions results in true only when x is a blue number and false otherwise? Does that question make sense? I want to pick out whether x is one of these blue numbers and not one of the other ones. All right? So which of these produces true only when x is one of the blue ones? See if you can figure that out and help each other.
Okay.
Give you 2 minutes to discuss.
I think I was
Do we remember our truth tables? Hopefully from the midterm, we remember our truth tables. Means greater than or equal to. Just one big thing. 2 characters. False for any others. Like if x was 12, it would be false. If it was 13, that's true. We're not sure which one x is, but we want it to be one of the blue ones. Check if it is. All right, that is my timer. Let's see what we thought. Get your best guess in if you're still thinking about it. Let's see here. I want to look at that. Okay. Let's see. Do we have any majority? Ooh, we're thinking maybe D. Is that a majority? Yeah, 6. Just barely a majority. Nice. Perfect. So let's see. Let's see what we got here. So the answer is in fact D, so good job. Let's talk about why. So A is not good enough, right? Because it's returning true if x is greater than or equal to 4. So it's like if x is anywhere on this side of that bracket, right, from there onwards. And then this is trying to rein it in from the other side, right, if x is less than or equal to 15. So do you see how that would be true for any of those numbers within this range? That's A. That's what A is going to give back. So like if x was 11 or 12 or 9 or 10, it would still give back true because it's within that range. You see how that's checking that? So that's not good enough. That's not good enough. All right. So that means we need like an OR. OR is going to pick out one piece or another. That's what we need here. So all right, how about B? X is greater than 4, strictly greater than 4. So that misses the 4. You see that? And it's less than 8, strictly less than 8. So that's picking out 5, 6, and 7. Or x is greater than 13, strictly greater than, so it's missing the 13. And then x is less than 15. So strictly less than 15, so that's picking out the 14. See how that wasn't good enough? It's picking out fewer things, but it's close. Maybe if you had some equal signs in there, that would have fixed it. You see the problem with that one, though? Please yell at me if you don't see it. I'll try to re-explain it. Then this one's getting better. It's like if x is greater than or equal to 4, so that's picking that out this side from then onwards. And then you're reining it in on the other side with this one. X is less than 8, strictly less than, so that's missing the 8, sadly. X is greater than 12, that's good. X is less than 16, that's good. That was almost perfect, but it missed the 8. See that? The last one works. Last one is x is strictly greater than 3, so that is from 4 onwards. And it's less than or equal to 8, so that's from 8 downwards, that's perfect, that's that range. Or x is greater than or equal to 13, perfect, that picks out 13 and bigger. And strictly smaller than 16, so that's not including 16, but anything below it, including 15. Do you see how D is going to pick out exactly that blue range? Are there any questions about that? That was a good example to study, I think. That's a very common thing to do in code. Like pick out, like this, is it part of this little range, or this little range, or this little range that I care about? That's important. All right, so if we are good, let's continue. Let's talk about, it's not an if-else block, it's an if-else statement in Python. All right, so let's go there. Where do I want to put this? I'll make a new file eventually. But here's an if statement. So an if statement in Python is going to test some condition. There's an if by itself, and then there's an if else. So I'll give you both. This is the one by itself. You say, let me just write you the syntax first. You say if, and then you give some big long potentially thing that results in true or false. That's your condition. So you fill this in with a Boolean expression, and then you put a colon, and then idle will do this for you, but you need to tab over. You need to indent, because you can't put blocks, right? Blocks inside of blocks. This is like a tab. You tab over, and then you put on as many lines as you need all the code that you want to run, code to execute, when that condition is true. When cond is true. That's what you do. And then once you're done with all the things you want to have happen when cond is true, you just untab. You go back out to the normal straight line code down here. And then you just have your regular code again. Regular code, you're outside of the if at that point, after you unindent. Regular code here is always executed as normal. Okay, so that's going to be the goal. That's an if statement. So if the condition is true, all that indented code will run. If it's false, it will not run. That's what's controlling it, all right? And then after you're done with your indented code, the body of the if is how you say it. That's what it's called. Then you unindent, and it will just continue with everything that's unindented down here after it's finished. Or if it just skips over it, it'll go straight to there. Okay, so that's an if statement. So let me show you an example of that. I'll make a new file. And I will call it maybe conditionals.py. Well, that seems like a decent name to me. So I'll save this as conditionals.py. And so here's an example. Let's set next variable to 7. And then I'll be like, if x is greater than 10. Right? That's false, isn't it? 7 is not greater than 10. But if it is, like I'll print it. Print x is greater than 10. Exclamation point. And then I can do things with x. X equals x plus 1. Print x. I can do whatever I want up in here. This is just all the body of the if statement. It's what's going to get run if this is true. So actually, let's start it out. Let's say x is 11 to begin. Okay. So if x is greater than 10, and it is now, all this indented code will run. That's the goal. And then after you're done, you unindent. You can be like just every other line that you want to always have run. Everything that's unindented is not part of the if. It's just this, just normal code again. This line always gets executed. It's just straight line normal code again. Print 2 plus 2. Those will always get run, right? But sometimes these lines will run and sometimes they will not, based on the condition. That's the power of it. So let's run this. We will see it work because 11 is greater than 10. So it's like, yeah, x is greater than 10. So it runs all these lines. Like it makes x 11, or sorry, it makes it 12, I guess, and it prints the 12. And then we're done with the if. We unindent, and then these lines always run. All right. So regardless of whether we ran this if, these lines run. It's not part of it. Okay. So if x was 7 again, now it's false, right? 7 is not greater than 10, so it skips over all this. That's how you can control it. And then it just jumps to the end of all that and goes to the rest of the normal code that's unindented. All those lines always run. Okay? Any questions about that? Does that make sense? This is an if statement that, based on a condition, either runs the thing that's indented or does not run it. That's called the body. It runs the body or it does not. All right. Because that's the equivalent of the if-then block in Scratch. The equivalent of the if-then-else block in Scratch is an if-else statement. So let's talk about that one, because sometimes you want to do one thing if it's true, one thing if it's false, something different if it's false, and that's what if-else gives you. So it looks like, or first of all, it's going to execute like this. You have some condition, and that will either result in true or false. And an if-else statement allows you to do one thing. It allows you to do the true stuff, we'll call it, if it's true. And then it allows you to do the false stuff if it's false. So it gives you options, which is nice. And then once you're done with one or the other, again, you unindent. You're outside of all of that. And then you can go down here and always run the same straight line code again. That'll all work out. But the syntax for that is very similar. It's if you give your condition again, the thing that results in true or false. You put a colon, then you indent over and give as many lines as you need for the true stuff, and then you unindent and you say else, colon, and then you indent and you give all the false stuff, the stuff you want to have happen when it's false. That's all. That's the new piece. You can have as many lines of those as you want, though. But it's like, if the condition is true, do the true stuff. Otherwise, else, do the false stuff. That's how you read it. So let's try that. I'll separate it with a comment. So let's make a new variable. Let's be like, y is, I don't know, y is 11 again. I'll start off with 11, and we'll be like, if y is greater than 10. Do one thing. I don't know, y is greater than 10. Something silly. And then if that's not true, I can have an else part. Else, maybe print y is not greater than 10. But you could have as many lines as you want, doing much fancier things. All right, that's the idea. And then once you're done with the body of your else, you can unindent, and now you're outside of the whole if-else statement. And now you're back to normal code that will always be run. Print always executed again, because it's not part of either of them because it's not indented, right? So running this, y is 11, it's greater than 10, so it will choose this one. It will choose the true branch, we say, and then skip over this one. It'll do this line, y is greater than 10, and then always execute it again. So that's just not part of it. It always runs. So there it is. We see that. And then if I make y smaller or equal to 10, if I make y 9, let's say, and rerun it, this will be false now. Y greater than 10? No, that's false. 9 is not greater than 10, so it'll hit the else part. It'll hit the false branch. Run this line, and then be done with the whole thing, and run this line down here. So y is not greater than 10. Always execute it again. Are there any questions about that? Does that make enough sense? It's very similar to Scratch. It's just you're using indentation rather than like putting blocks inside of blocks. So we are comfortable with that in Scratch. I think it's not too horrible, I hope. There is one last thing that does not exist in Scratch. It's like a combination of multiple ifs and elses. That's how you would have done it in Scratch. There's a quicker and cooler way in Python. So let me show that to you if we're ready. Any last questions about any of this? Does it make enough sense? All right. So it's called an if-elif else statement. So elif is like in the middle. And you can have as many elifs as you want, right? Because sometimes your code gets a little ugly. Maybe you need multiple if-elses inside of if-elses. And a very good example of that is like if you want to calculate somebody's grade. All right, like Canvas is doing this code. It looks a little weird with just if and else. Let me show that to you. So here is kind of how you calculate somebody's grade, right? It's like you check the grade. If it's greater than or equal to 90, then you know that's an A, right? If not, let's say that, like, this is a very simple example. Let's say that there's no B's and D's, it's only A, C, or F. And then you check, all right, if it's not an A, maybe if it's still greater than or equal to 70, then we give it a C. That's your grade. And then otherwise, else, you give an F. Okay? That kind of thing. You could make this this grade calculation program, ask the user for a score, and you could use ifs and elses. You'd have to nest them, put one inside of the other to make this work. But there's something called elif that's going to make it better. But essentially, here's what you'd have to do. Here's how this program would work in like a flowchart form. It's like first you got to check, hey, is that grade greater than or equal to 90? If that's true, then give back A. That's the grade. Otherwise, if that's false, you're not sure if it's a C or an F yet. You have to do another if else. Does that make sense? Otherwise, all right, it wasn't an A. Maybe it's a C or an F. I'm not sure. Let's check. So if it's greater than or equal to 70 now, then I know if that's true, it must be a C. Otherwise, it's an F. All right? And that's the idea. So let's code this up. Why not? And then I'll show you a better way with this thing called elif. Okay? So let's see here. We'll make a new file. Make it small again. And then I will ask the user to give me a grade. So grade is equal to input. Enter your grade or something. Colon space. And then we're getting a number from the user. We don't want it to be a stir, right? We want to do number comparisons with it. So we're going to convert it to maybe this. Usually your grade as a percentage has decimal points. So it's going to be a float, I would say. Let's convert it to the float type. And then now we can check A, C, or F. So the first thing we check, we're implementing this flowchart, is, all right, is the grade greater than or equal to 90 or 90.0, whatever you want to call it. If that's true, then you know immediately it's an A, right? Print A. And then it gets a little ugly because here else, you're not sure still. Like it's either C or an F if you got here, right? Could be C or F. And so your only hope to figure out which one it is another if else. You see that? You have to nest them. So if, all right, let's see if it's a C or F. If the grade is greater than or equal to 70, 70.0, I guess. Or just 70 is fine, honestly. Then it's a C. Otherwise, if that wasn't true, it must have been even smaller, else print F. Does that make sense? That's going to, and I'll call this what? Elif, because I'm about to show you a cooler way called Elif. This will work. This will give you A, C, or F based on your grade. So like enter your grade 92, A. Enter your grade, I don't know, 75.5, C. Enter your grade 65.7, F. It's going to hit each of them. It's going to do the right thing. Does it make sense? Like you need multiple if-elses. Another if-else inside the else, the outer else. Because you're not sure when you get here. Like, it wasn't an A, but I need to figure out if it's a C or an F still. It's another question to ask. Any questions about that? So, that gets a little wonky, I would say. It looks a little ugly doing it like this. You can imagine if you added checking for B and D, like you'd have so many, you'd be indenting so far by the time you got to check for D or F. I think you can imagine that, right? there is a solution. It's called elif. It makes it look a little bit cleaner, I would say, and you will grow to prefer this way, I think. So elif is short for else if. It's like a combination of the two. And apparently I cannot get rid of those underlines, sorry. So elif stands for else if. It's like an else and an if together, which is kind of cool. And I would like you to read elif as like the word otherwise. Read it as otherwise. Whatever. So here's the idea. Here's how elif looks in the context of a big long if, elif, else statement. So you're like, if the condition, this first condition is true, do one thing. That's normal. If the condition 1 is true, do the body number 1. Then you start saying elif. You start saying elif a lot. So not else, but elif. And then you give another condition. Elif cond 2. Try that one if the first one didn't work. If that one's true, do body number 2. And then you can have as many elifs as you would like. They always test another condition. They're like, elif, some condition number, I don't know, condition number K, I'm not sure. And then do body number K. You have as many options as you like. And then finally you can finish it off like if none of those conditions passed, and I didn't do any of those bodies, then else. Else, if none of that's true, do this thing, body K plus 1. And the idea is, it's going to try one or the other. It's going to try the first condition that works. Right? This con 2 will only ever get checked if con 1 fails. It's like a combination of else if you read it as otherwise. If con 1 is true, do body 1. You're done with the whole darn thing. Otherwise, check if con 2 is true. Then do body 2. If that's not true, otherwise, go all the way down to here maybe. Try con K, do body K if that's true. Otherwise, if that's not true, do this one. So you're getting options, right? So this is it's all one big chunk. You think of it that way. Only one of these bodies is ever going to run. And this condition is only ever checked, only ever tried, if cond 1 fails, if it's false. It's trying to find the first thing that's true. Okay? That's the idea. That's elif in a nutshell. And then, like, if none of these were true, none of the conditions were true, it didn't run any of the bodies, you hit the else, and that one only ever happens if every single condition was false. Only run if every condition was false. Okay? So try to read elif as otherwise, and let me show you a good example of using it. So you can get rid of this indentation if you use elif. So, I don't know, alternatively, using if elif, else, you only need one elif for this one. But watch how this works. First, you still check, hey, is grade greater than or equal to 90, print A. And then it's like, elif. Otherwise, all right, let's try the C option. If it's greater than or equal to 70, print C. And then if that's not true, then print F. I think that's cleaner in my mind. Are you reading it the same as I'm reading it? So these are equivalent. You can do it this way, or you can do it this way. Either way works. Any questions about that? So let's try running it. Enter your grade, 95. They both print A. Enter your grade, 75. They both print C. Enter your grade, 65. They both print F. They are doing the exact same thing. This way maybe makes a bit more sense, like it matches the flow chart a little bit better that I drew first. Like those are your options. You have to check those things in order. But eventually you might prefer this way. That's the idea. Yeah. Any questions about how these two pieces of code are doing the same thing? They match this flowchart. All right. If we are happy, let's shift gears to Turtle Land.
Okay.
Now we have some new tools that we could use in Turtle Land. And, oops. Oh, sorry, I forgot to give me a second. I forgot to clear out some things. That's weird. I wanted this to be blank. Apparently it didn't save. Sorry. I'll fix all that later. There we go. Now I will reconnect. It's trying. Alright, that's better. So I want to show you how to draw with color. Make colorful pictures and shapes. So let's learn how to make our lines something other than black, first of all. If you go to the turtle library, it will tell you more about this. So feel free to go there. Have we all done attendance? Can I stop that? Another minute. You search for Python turtle. So you go there. And you have some options down here. Here are all the functions inside the library. It's going to be pen color. Pen color is the color that the turtle's tail is drawn lines with. And you can set that to like some string of a color, like pen color brown, pen color red, blah, blah, blah. So here's how you do it. So if you say turtle.pen color red, that will then, your little turtle who was drawing lines with black. There he is with his tail. Now he has dipped his tail in red ink. And he's about to draw lines with red. That's the idea. So if you say turtle.pen color red and you start moving the turtle, it'll draw a red line. And then you could come right back and say turtle.pen color blue, and it'll start drawing a blue line. And you move them from there. So it's like the red line became a blue line. It's kind of cool. So the default is, of course, black, but now you know how to change it. So let me show you that. I'll make a new file for turtle stuff. And I will say, of course, import turtle. Get the library, first of all. Make the turtle shape a turtle like I like to do. And then you can say turtle.pen color red as a string. And it can be like turtle dot, then you move the turtle dot forward, go 100 units forward, turtle dot left 90 or something. So that'll draw a red line. And then move the turtle. So colored lines dot py. If I run this, there, and you can see the outline of the turtle tells you what color he's going to draw with if you moved him. It's kind of nice. So we got a red line for once. And then you can do the same, like turtle.pen color blue, and go forward now, and you will draw blue lines. The turtle understands most colors. And so now we have a red line and a blue line. I don't know what else to say about that. I hope that makes sense. That's just another function in the turtle library that lets you make cooler things. Any questions about that?
Hold on. Let me just work this one. Let me just make sure this works.
So yeah, let's go and talk about filling in your lines now. Let's make shapes that are actually colored in. Like you know how to draw a square, but why can't you draw a filled square?
Yay!
So that'll work. So let me show that to you. That's the fill color part of the turtle, by the way. So there's a pen color, and then there's also a fill color. And you can ask the turtle to fill in stuff. All right? And so the secret is, you can set the fill color to green, for example. And then you start drawing stuff. But first, the turtle has to be reminded, like, I would like you to fill in this next shape I'm about to draw, Mr. Turtle. And so you got to tell him that. So he doesn't know, like, whether or not you want something filled in. So you have to tell him when you do. And so you say turtle.begin_fill. And then turtle.end_fill. You wrap those around your shape drawing. All right? So you say begin fill. Then you start drawing your shape. You close it off. And then once you say end fill, that's when the turtle goes and it's like, all right, I'll fill that in for you. So you have to use begin fill and end fill between every shape that you draw if you want it filled in. That's just how you tell the turtle you want that. Okay? That's the idea. And let me show that to you. Let's see, is there... I assume it's here too. Turtle.begin fill, end fill. There it is, filling. begin fill, end fill. These are some examples if you want to look at them. I guess before you start drawing the shape, say begin fill. After you draw the shape, say end fill. That will close it off and color it in. So let's draw, I don't know, let's draw a square or something. Let's fill in. So I'll say, I'll probably steal a lot of this, so I'll steal some of this file. I'll make a new file called filled shapes, I guess. Filled shapes.py. Oops, not that, but that. Make this smaller. Go back to there. And instead of doing pen color stuff, I will say turtle.fillColor. Fill color green, let's say. Let's make a green square. Green the string. And then we draw a square. I guess we could do what we did. Honestly, we can keep the colors of the lines too. Those are separate technically. Let's go back to that. Where are my colored lines? There they are. I'll honestly keep these. Why not? There. Red, then we'll just have it keep on switching between red and blue. Why not? So left 90. And so if I do that twice, I believe, that will draw a square. And so let's run this so far. And the turtle colors himself in by what his fill color is. So like, we've got a square right now with red and blue lines, but we didn't say begin and end fill. That's the last piece of this puzzle. We say, before we start drawing our shape, right before we do, we say start filling, please. So turtle.begin underscore fill. We call that. And then once you're done, you say turtle.end fill. Just like that. And now, because you added that, you will get a filled in square. And you still have line color, just harder to see. So yeah, that's the idea. Just wrap begin and end fill around all your shapes, and they will be colored in with whatever fill color you set before you made that shape. Or technically, maybe you can set the fill color right before you end the shape. I'm not sure, honestly. I've never tried it that way, but I imagine that would work. Any questions about that? It's kind of cool. All right. I have a couple more examples if we're good. I want to talk about a wonderful library that's going to make so many cool things for us the rest of the semester. It's called the Random Library. That's where you can generate random numbers and use those to control your program randomly. Like, think of every video game, right? You have, like, it's different every time because of randomness. And so somebody's using a random library to make a game, to make cool, abstract, random-looking art. This is going to be a very good thing. So let's go and look at the library for that. It's the Random Library, Python Random. That one, you import that, of course. And then you can ask for a bunch of stuff. The ones that we're going to use, I think we're going to use mostly random.randint. That generates a random integer between the two values that you give. Like, I want a random integer between 1 and 100. So you'll call random.randint with 1 and 100 as the arguments. That's going to be the idea. There's also random.choice that we will use eventually. That like takes a random thing out of like a bag of stuff. We have to learn how to make bags of things first. So that's let's do random.randint, right? So you can call it, and it gives you a random number between 1 and 10, set that to a variable maybe, and you can then go and print it out, and like use that to like control a turtle, like go this many steps, stuff like that. It's kind of cool. So let me just show you that in one file by itself, and then we'll go from there. So it's the Random Library. You say import random, just like every other library, and now you have the access. You have access to that library and all of the functions in it. Random.randint between 1 and 10, and that will give you a random number back between 1 and 10, and I guess technically I could have just copied and pasted it. There. Random number between 1 and 10, that line sets it into the n variable, and then you can go and print that, and it will be different every time you run the program because it's random. I'll call this randomness.py. Do not name this file random. Remember the problem that I showed you before? Every library is secretly like somebody's looking for random.py. That's where the library was made. Don't make your own file called random.py. Then it will forget about where the real random library is. Just like you can't name a file turtle or math. Don't name a file random.py. So I'll call it randomness.py. And apparently the random number that came up with this time was 6. And obviously, it's random. So if I rerun this, I'll get a new random number. Now this time it's 9. Now this time it's 7. Now this time it's 2. And eventually it will repeat, of course. But isn't that fun? You can use that to control your program in a random way. How fun is that? Yeah. Any questions about that?
What was that hashtag gives a what?
Gives a random number between 1 and 10. Just reminding you what it does. That's that comment. Alright. So yeah, remember the import random. And then you can go and use all of the functions in the random library. Yeah, so for my last trick, let's use that idea of randomness to draw a random square somewhere on the screen. Alright, so let's make a square, or maybe multiple squares, I don't know. If we copy and paste it, technically we can do that. Let's make a random square with a random size and a random location. So maybe it's a big square when you run the program, maybe it's a small square, maybe it's in the upper left corner once, maybe it's in the lower right corner the next time. So it's random. So we have to think about what do we want to generate? Like, what does it mean to be a random square? Right? We have to pick how we represent the square, I guess. That's important. So let's do it like this. Let's be like, what does it mean to draw a random square? How do we draw a normal square? Right? We go somewhere, and then we start like going forward, face east, go forward a little bit, turn left, go forward the same amount, turn left, go forward the same amount, turn left, go forward the same amount. So we need to know the starting point, like the lower left coordinate of the square, and then also how wide we want it to be. Do you see how you can make random versions of those by just picking random starting locations and starting lengths? All right, that's going to be the goal. So like pick a random starting point with a pen up and go there. It's like we'll make a starting x variable. And that will be set to something random between like, I don't know, negative 250 and positive 250. So like maybe this time it's negative 200 randomly. And then we'll also need a starting y variable. Starting y. Another random number between like negative 250 and positive 250. Maybe this one's 100. And then we got to pick a side length for it. So here's how we like pick the starting x. Maybe it's negative 200. Whatever you want it to be. Yay. And then you pick how big you want it to be. Like, all right, if that was your starting x and starting y, go here. And then like go forward by the size of your square each time. Just keep turning, right? So pick a random side length too. Square side length is some random number. Square side length. Maybe this time it's 150 and you draw a big square. I don't know. But do you see how those three variables, depending on what they are, they tell you how to draw a square if you do the rest yourself. And you can use them to draw any square. It's just random. You go to some starting point, interpret that as the lower left coordinate of the square, and then just start drawing. And then just start drawing. Maybe it's big this time. Maybe it's medium-sized over here. I don't know. Maybe it's baby and tiny over here. But it's just like it's got a starting coordinate, and then it has a size. That's all you need to draw a square. You do the rest. Isn't that fun?
It is fun.
So let's do that. Let's get that working first, and then we'll make it cooler. We'll have it filled in. So let's start with that. Let's see, I'll steal most of this filled shape stuff, I guess. Copy that into a new file. And I'll call this randomsquares.py. And so don't worry about like the fill color right now. I'll get rid of that. I'll get rid of the begin fill and the end fill too. For now. And then like here's drawing a square with weird side colors. Let's get rid of those. let's just have the square drawing part, right? So this code draws a square right now. I hope that makes sense. Technically, you don't even need this last one. You don't need this left 90 at the end. That's fine. But let's make it a random size square. Right now, like the turtle is at 0, 0, and we're drawing a square. Let's get some starting coordinates for this thing. All right, let's get a starting x, a starting y. Let's pick them randomly. It's like the x coordinate where I want to start drawing the square from. That's random. I'll import the random library too. I need that. Random dot rand int between, let's say, -200 and 200. Cool. Same for starting y. I don't know what it's going to be. It's going to be different every time. And I'll use that to draw my square. And then I also need a side length. So square side length is some random number between, we want a positive side length, so let's make it 50 and 200, let's say. And with these, that is describe the square. So we need to go to starting x, starting y with like turtle.goto. Starting x, starting y. So that's like go to the random starting point. And then we also want to face east, because that's supposed to be the lower left coordinate of our square, so we want to face to the right. And face east if we weren't already. So it's going to be turtle.up, first of all. Don't make marks as you're going to this random spot. Then turtle.set heading, and it's 0 for east. 0 degrees. Starting from the normal starting point for degrees, to the right. And then turtle.down, because now I do want to start drawing this square. I'm there, okay? And now I don't want to draw 100 by 100 square, because this is going forward, 100, forward, 100, forward, 100. I want to draw a square of this random side length. So I'm going to go forward by whatever that was. Does that make sense? It's like whatever got filled in there, that's the side length for my square. I'm using these variables that hold random values. I hope that makes enough sense. Are there any questions about that? Does that idea make enough sense in our minds? That's what's going on there. And in theory, that should draw a square at a random place. Let's see if it works. Cool, so we got like a decent sized square up there. Nice. And if I rerun this, it's going to choose different places for this square. Now it's more in the middle. Similar size this time, though. Now it's way over there. Still similar size. Oh, that's funny. That's randomness for you. Let's get a tiny one. Okay, this one's bigger. Where are our tiny squares? That's a little bit better. Now it's down in that direction. So it's making a random square. Because those three variables are all you need to know to like describe a square. And then we went and drew it with those variables in mind. Any questions about that so far? That's pretty fun. This is going to make a cool final program, I think. So that's the start of it. Let's fill it in. Let's ask the user this time what color they want it to be filled in with. So it's different every time as well in that regard. So we'll ask the user, hey, what color do you want this square to be? This random square. So we'll say, I don't know, input, enter the color. And we'll get that as a stir, which is exactly what we need to give to fill color anyway. So we'll set this into a variable, color to use, get the color from the user, and we'll set the fill color to that, turtle.fill color. So we're using variables for a lot of stuff right now. Fill color becomes color to use. Cool. And so then this will set the fill color to that. And then if I draw the square with the begin and end fill, right? Turtle.begin fill, and then end fill at the end of the square as well. It will fill in that square with that fill color that the user chose. That's kind of cool. So let's make a green square. So it stopped. It's asking us right here, enter the color first. So green. Hit enter, and then it changes the fill color, goes to a random spot, and fills in a green square randomly. And then if I run that again, and I say red, enter, it sets the fill color to red and draws a random red square. So that's pretty fun. Alrighty, blue. A random blue square way over there. You can extend this window, by the way, if you want to see it all. But that's it. are there any questions about what we've got so far? So we're getting a color from the user, setting the fill color, using those library functions. Then we're using randomness to figure out where to draw the square, and then we're going off and drawing it there. Filled in. How fun is that? So I think for the last thing that I want to show you is let's draw 5 random squares in total. So I haven't showed you how to loop yet, so you're kind of forced to, unfortunately, just copy and paste all this, because you need a new random starting point and side length every time. So if you just duplicate this code 5 times, it will draw 5 squares. Boop. And that's the second time. There's a third time, fourth time, fifth time. That'll do it. So just a bunch of this code repeated 5 times. So it'll always pick new places, right? New random starting X, starting Y, side length. It's going to go there and start drawing. Same original fill color though, just the one from the start. But I've duplicated the square drawing code in the randomness part 5 times, so it'll draw 5 squares. Oops, cancel, run, save. I don't know, what's the color that I haven't picked yet? Pink. Pink squares, 5 of them. 1, 2. And so we are on our way to making interesting looking abstract art. How fun is that? What's another color I haven't picked yet? Yellow. And it's random every time. Of course, this will be a different picture. Are there any questions about how the code that we wrote and then duplicated a bunch of times ends up with this result? That's a fun program to study, I think. So, if you're ready, if you're happy enough, let me introduce your next programming assignment, and I think that'll be it for the day. So, programming assignment 6. This is a very old video, but it's based on a silly video on YouTube about green not being a creative color. If you've seen that before, it's a very trippy video. Feel free to not watch it. But the idea is you're not going to allow green in this program. So I'm forcing you to use an if statement, all right? So here's your program, program assignment 6. You got 2 weeks to do it. So write a Python program, please, that uses the turtle and random modules, just like I did. And I want you to draw not 5 squares, but 10 triangles of random size and location, all right? You can pick any kind of triangle. I think equilateral triangles like we've done in class are the easiest, so go for those if you'd like. Or give yourself a challenge, it doesn't matter. I would like you to ask the user for a fill color, just like I did, and then set the fill color to whatever that was, except if the user wanted green, because green is not a creative color, right? So if the user asks you to use green, then you must disobey them. You must pick some other color, all right? Pick some other color or yell at them and stop the program. Some way you do not allow green triangles, okay? Does everybody understand the objective? So that's forcing you to use an if statement, okay? That's why we're doing that. You can change the fill to be something other than green. I think that would be the easiest idea. Just change it to be red or who cares? Whatever your favorite color. That's not green, all right? So you can reuse pretty much a lot of what I've given you, and please make it fun on yourself. But yeah, that's the idea. This was 5 random squares with a custom fill color. You're going to be doing 10 random triangles with a custom fill color, as long as that fill color is not green. All right, so make sure to check for that. But I think that's pretty much the program. Are there any questions about the assignment and what I'm asking?
I think I got it.
All right, so this will be due in 2 weeks, and as usual, please upload a video with an explanation, and that'll be that. Yeah, October 26th, apparently. If there are no questions, I think that was all. Yeah, so the rest of the time is yours to get started if you like.